The moon rocket is rolling back to the hangar. Again. And this time, it's because of a gas line the size of your arm, hiding inside a 130-meter stack of the most expensive machine humanity has ever. You're listening to Stardrift FM. Tonight, the Artemis II Rollback. What broke, what it costs, and who's waiting. A space telescope launching in 7 months, and somehow it's on time. A galaxy with tentacles, 8.5 billion years old. Supermassive black holes silencing their entire neighborhoods. The galaxies the early universe wasn't supposed to have yet. And India is sending a robot astronaut to orbit next month. Grab your coffee, let's go. So this morning, NASA's Space Launch System, the moon rocket, the big orange one, began rolling back from Launch Pad 39B at Kennedy Space Center. A 4-mile-per-hour crawl back to the vehicle assembly building, where it's going to sit while engineers figure out what went wrong. What went wrong is this. Overnight on February 21st, engineers detected interrupted flow of helium to the ICPS, the interim cryogenic propulsion stage, which is the upper stage sitting on top of the main rocket. Helium pressurizes the fuel tanks during ascent and purges the engines before ignition. Without it, the upper stage can't fire safely. 3 possible causes under investigation: a problem at the interface between the ground supply and the rocket, a valve failure inside the upper stage itself, or a clogged filter. Any repair requires physical access to the upper stage, and you can't do that on the launch pad, so back to the VAB it goes. This is the 4th delay. February 3rd, a hydrogen leak stopped the countdown 5 minutes from liftoff. March was waved off. The second wet dress rehearsal completed February 19th, and then this. April is now the earliest realistic window. 4 astronauts are waiting. Reed Wiseman, Victor Glover, who would be the first person of color to travel to the moon, Christina Koch, who would be the first woman, and Jeremy Hansen of the Canadian Space Agency, who would be the first non-American. All 4 are still waiting. And that brings us to the number. $4 billion. That's the cost of a single SLS launch. $4 billion to roll it out of the hangar, stack it, fuel it, and then in this case, roll it right back in. The Trump administration's own budget proposal called SLS grossly expensive. The GO has called it unaffordable. SpaceX built the entire Starship program for about $10 billion total, for a rocket that can carry 3 times the payload. Switching gears, because not everything in space is behind schedule. The Nancy Grace Roman Space Telescope is currently at NASA's Goddard Space Flight Center in Greenbelt, Maryland, where it's undergoing vibration and acoustic testing. Essentially, engineers shake it and blast it with sound to simulate what a rocket launch feels like. If it passes, it ships to Kennedy in June. Launch target September 2026 on a Falcon Heavy. Here's what makes Roman remarkable. Same mirror size as Hubble, 2.4 meters. But its field of view is 100 times larger. One single Roman exposure covers the same patch of sky that would take Hubble 100 separate pointings to photograph. Over its mission lifetime, Roman is expected to image 1 billion galaxies. 1 billion. It'll map dark energy, hunt exoplanets through gravitational microlensing, and directly image nearby planets with its coronagraph instrument. And here's the part that almost never happens with flagship space telescopes. Roman is on schedule and under budget, $3.9 billion. Compare that to JWST, $10 billion, 14 years late. Sometimes NASA gets it right. Now for something that sounds like science fiction, but is very much science. 8.5 billion years ago, when the universe was barely 5 billion years old, a galaxy was moving through a cluster of other galaxies. And as it moved, the thin, hot gas filling that cluster acted like a headwind. It hit the galaxy's own gas and pushed it backward, forming long, glowing trails behind the disk. Astronomers call these jellyfish galaxies. JWST just found one at record distance. Galaxy Cosmos 2020. Look, the name is a serial number, but what it shows is something that shouldn't be there yet. The tentacles are glowing blue because star formation is actually happening inside the stripped gas, outside the galaxy entirely. young star clusters less than 100 million years old, being born in gas that was ripped away from the main disk. The significance, Monell said this kind of galaxy cluster interaction was a late universe phenomenon. The clusters needed time to develop the density to strip galaxies this dramatically. This discovery pushes that timeline back by billions of years. It also tells us something about why so many galaxies today are red and quiet. Star formation long since faded. The stripping starts early and it's brutal. All right, this one is for the people who like their science a little dark. There's a quasar, a supermassive black hole in full feeding mode, called J0100+2802. It has a mass of 12 billion solar masses, 12 billion times the mass of our Sun. And it existed when the universe was less than 1 billion years old. JWST has imaged it directly. Now, astronomers have known for a while that active black holes like this one suppress star formation in their own host galaxy. They heat the gas, blast it with radiation. The gas can't cool and collapse into stars. But new research from the University of Arizona, published this week, found something more alarming. The influence extends to neighboring galaxies. Up to 1 million light-years away, the team measured oxygen emission signals, tracers of active star formation, in roughly 100 galaxies around J0100. Galaxies inside that million light-year radius show dramatically weaker signals. The quasar's radiation heats their interstellar gas, splits the molecular hydrogen, and star formation simply stops. This is a new picture of how galaxies evolve, or stop evolving. A single active black hole silencing everything in a sphere 10 Milky Ways across. Now, a mystery about galaxies that weren't supposed to exist yet. The Atacama Large Millimeter Array, 66 radio dishes in a Chilean desert, sees things optical telescopes can't. Dust specifically. Dust glows in millimeter wavelengths. And what ALMA has been fighting in combination with JWST is a population of massive, dusty, furiously star-forming galaxies from just 1 billion years after the Big Bang. A team of 48 astronomers from 14 countries, led by UMass Amherst, published their analysis this week. They identified around 70 of these galaxies, heavy with dust, rich with metals, forming stars at extraordinary rates. The problem, they shouldn't be this mature this early. Dust is made of carbon, silicon, oxygen, the ash of stars that have already lived and gone. But 1 billion years after the Big Bang, there wasn't supposed to be enough time for stars to be born, live their full lives, and leave behind that much dust. The presence of these galaxies means star formation started earlier and moved faster than our models predict. What makes this significant is where these galaxies fit in the timeline. We see very young galaxies at the very start. We see old, quenched red galaxies a bit later. But between those two, there was a gap. How did galaxies go from newborn to ancient so fast? These dusty galaxies are the answer. They're the ones doing all the work in between. The missing link. Hiding in the dust, invisible to every telescope we had before JWST and ALMA started working together. And finally, something to look forward to. Meet Philomitra. Her name combines the Sanskrit words for space and friend. She has a head, a torso, 2 arms, no legs, which she doesn't need in zero gravity. She's built from aluminum alloy. She monitors temperature, pressure, humidity, carbon dioxide, and radiation levels. She can operate switch panels, and she speaks both Hindi and English. Next month, she's going to space. Gaganyaan, India's first uncrewed test flight of its human spaceflight program, is scheduled for March 2026 from Satish Dhawan Space Center in Sriharikota. She'll fly in the Gaganyaan crew capsule to a low Earth orbit of 170 by 408 kilometers. Spend several days validating life support systems, then splash down in the Bay of Bengal. The whole Gaganyaan program, the robot test flights, 2 more uncrewed missions, and eventually a crewed launch in 2027 with 3 Indian astronauts. has cost about $1.4 billion total. Compare that to the $93 billion Artemis program, whose rocket started its journey back to the hangar this morning. If Gaganyaan succeeds, India joins the United States, Russia, and China as the only nations capable of putting humans in orbit on their own rocket. Not a bad club to be in. Tonight on Stardrift FM, Artemis II is rolling back to the VAB after a helium issue in the upper stage. April, now the earliest target. The Roman Space Telescope is on track for a September launch with a field of view 100 times larger than Hubble. JWST found a Jellyfish Galaxy from 8.5 billion years ago, proving galaxy clusters were already stripping their neighbors when the universe was barely 5 billion years old. Supermassive black holes, it turns out, silence star formation not just in their own galaxies, but in everything within a million light-years. A population of dusty galaxies from 1 billion years after the Big Bang is filling in a gap we didn't know how to explain. And next month, India sends a robot to space. This is Stardrift FM. Thanks for tuning in.